Chalk Talk is brought to you by Isolite, the emergency lighting experts. Stay educated, my friends.
The world needs demonstration more than it needs teaching. That's a quote from the very famous Wallace D. Wattles. I did verify that it is a real person. He was an author in the 1800s, but it's an appropriate quote because Tom Deutsch, our sales support engineer, will be running the call today. And he's put together a demonstration for us in AGI32 that's received some tremendous feedback on the first 3 Chalk Talks that we've done. So I trust it'll be valuable for everyone on the call today. Hello, everyone. My name is Matt Bird, the Eastern Regional Manager, along with Greg Keel, our Western Regional Sales Manager. Really excited to have you with us for our last of 4 Chalk Talks focusing on AGI32. As a reminder, your line is muted, so if you do have questions throughout this or at the end, please utilize the Q&A feature. With that said, I'll turn it over to Tom Deutsch to go ahead and run with it.
Thanks, Matt. What's going on, everybody? Welcome back to another Electric Chalk Talk presented by Isolite. Today we're going to be talking about emergency lighting layouts in AGI32. As always, we will do this in 3 parts. First, real quick, we're going to go over some code. Then we're going to run you through an example. I call this the hallway example. We're going to be building a hallway. We're going to talk about what we need first, the prerequisites, and then we're going to run right into the 5 steps. We're going to build the room, define the luminaire, place our luminaires, insert our path of egress, and then adjust to meet code and do a little bit of troubleshooting. Finally, we'll go over sales and marketing. Real quick, NFPA 101 mandates that you must have an average of 1 foot candle along the entire path of egress, and at no point in that path of egress can you have any less than 0.1 foot candle. Additionally, you must maintain a ratio of maximum illumination to minimum illumination less than 40:1. So for example, if you had only 0.1 foot candle at any point along that path of egress, you are not allowed to have any more than 4 foot candles along any part of that path of egress. So please keep aware that there may be some jurisdictional differences. I am aware that some locales do have some more stricter rules for foot candles, like maybe 2 foot candles average and 0.2 minimum. So let's keep rolling along here. For our example, and when you're going to lay out a emergency lighting space in AGI32 yourself, what you're going to need is either a CAD file. This is going to be inserted as a backdrop, or you're going to have to know the dimensions of your space. You're going to have to know where you want to mount these fixtures in terms of height. You're going to have to know what your ceiling height is, and you're going to need an IES file for all the fixtures that you're trying to run through AGI, and you're going to need a little bit of AGI skill. You're going to see that AGI is as much an art as it is a science. These are the 5 main steps to building an emergency lighting layout in AGI32. If you can do these 5 things, you should be able to be successful. The first one you're going to see in a second here in our demonstration. We're going to build the room. Then we are going to define our luminaires using an IES file. And we're going to see it matters if we have just per head or per fixture IES files. Step 3, we're going to locate and aim these luminaires. This is going to be placing our luminaires into our room that we built, making sure to input mounting height. Step 4, we're going to build our path of egress with calculation points, keeping in mind we want at least a 4 foot path of egress if we can do it. Step 5, we're going to adjust to meet code. It is never correct the first time unless you get really lucky. So you're usually going to have to do a little bit of adjusting on your luminaires. I'll teach you how to do that. And we're going to utilize rendering mode for some troubleshooting. Now, without too much further ado, I'm going to let me from a little bit ago, I think I recorded this yesterday. Let me just play this for you. A little demonstration. So we load in AGI32. And our first step is to build the room. So we're going to go to Rooms Objects, and we're going to press this button right here to build our room. Notice right here we have all our reflectances, 0.8, 0.5, and 0.2 are industry standard. We're just going to keep them right at where they are. If you do happen to know what these numbers actually are for the space in real life, you can go ahead and insert them here, but typically we're just going to keep them right where they are. and we will get pretty accurate results. In this example, we have a 10-foot wall height, so we're going to go ahead and put our wall height in right now. Going to make our orientation point a little easier to find, and we're going to start by clicking right at 0, 0. In this example, we know that we have a 150-foot long hallway. So at the bottom left, you see it says 150, 0. I'm going to tap there, and following along, I know that it's 60 feet tall. I'm going to tap there, by 10 foot wide. So I'm going to go to 140, and tap there. Continuing down. I do know that this hallway is U-shaped. It does come back up. So I place one at 10, 10. We're going to continue to build out our room. And final tap. Now we have this. We can right click and our room is built. We're going to turn calculation points on, and we are going to set our work plane height at 0. This sets our calculation points to the ground so that we are measuring foot candles at the floor level right where we want to. I'm going to press OK. And that brings us right to step 2, which is to define the luminaire with an IES file. So we're going to hit luminaire, we're going to hit define, and we're going to hit browse recent. We're going to find our IES file, double click on it. We're going to set it to photometric center for both vertical and horizontal. We're going to press OK. We're going to see listed here the lumens of the luminaire. This says 650. I know, as per the Isolite website and the spec sheet for the bug, which is the fixture we're using, I know that each head on that is advertised at 650 lumens. So what that means is that this IES file is for just one head, not for the entire fixture. And that's a good thing. That's going to allow us to aim each head in an independent direction, which we want because that makes things easier. Just keep in mind that every time we place a luminaire, we'll have to place 2. Now that brings us right to step 3, which is to locate and aim the luminaire. So we do have 3 options here. Locate, we'll just place it and it's always going to face the same direction. Locate and orient, it will face any direction you choose. But locate and aim, it will face any direction you choose. And then it will also, you can point at what distance you want it to point at from on the floor. So I'm going to go ahead and place one right here because I'm going to eyeball this and I'm going to sort of give it my best guess. And I'm going to aim it right here. So that's where, if you were looking directly into the bulb here, it is pointed directly at this point on the ground. Well, we have 2 heads. We get to aim one over in this direction. And we're just going to try centering them on these walls as our first guess to see if that works and to see if we're able to meet code that way. Same thing for this wall. I'm just going to mirror the one on the other side. Next, we are going to build our path of egress with calculation points. So we're going to go over to our third category we're using over here. This is calculations. And we are going to press on this. And typically you want either a 4-foot or a 6-foot path of egress. But before we do that, we're going to set our calculation points to be 2 feet apart themselves. If they're 10 feet apart, we certainly wouldn't have enough of them, so we need to change that. We also want a label to tell us, a summary, to tell us if we are meeting code. So we are going to go ahead and include the following information, which is our ratio, our minimum, and our average. I'm going to make sure elevation is set to 0, and we're going to press OK. Next thing we have to do is draw it. So we're going to pretend in this scenario that we have an exit drawn in over here and an exit drawn in over here. So we're going to start our path of egress. If we're going for 4 feet, we'll start at 3 and we'll just make it 3 feet around. So I'll go down to 3 and I'm just drawing our path of egress here. Going all the way up to here because this is our exit. And when we're done, we're going to right click. And that will insert our path of egress. If you look really close, you can see the calculation points for that. And you can see our summary listed below as well. Zooming back out now. We're going to press the calculate button and we're going to see if our initial guess has succeeded in meeting code. So we're looking for at least 1 foot candle of average, and we definitely do not have 1 foot candle of average. We're looking for a minimum of 0.1 and a maximum. Well, our maximum can be anything. But we can tell that something definitely went wrong here. We're seeing 0.1s and everything. This is the point where I would stop and say, okay, this is abnormal. Let's check the render button and see what's going on here. And if we look, look at our luminaires. They're on the floor. So that means we know exactly what we need to fix. Go back to model. And what we were supposed to do when we placed our luminaires is specify their mounting height at 8 feet. We didn't do that, and so they're all on the floor. And that's why that render tool can be really helpful for letting you know what you did wrong, because you could sit here getting confused and spending a lot of time trying to figure out what went wrong when you can just visually see it with render. So we're going to go and we are going to use the edit luminaire tool, and we are going to click on all these luminaires. We're going to make sure they're all selected, all 6 of them, until they all turn gray, and we're going to press the enter button. Here we can edit our luminaires. We can translate them along the X and Y axis, but also along the Z axis for height. We know we want them all to be at 8 feet, so we're going to go ahead and press 8 feet for all of them, and then we're just going to press OK. Now our points are going to turn to question marks because we need to recalculate because something has changed in our file. So we're going to press calculate. And our new numbers are in, and let's see what we got. Our average is only 0.57, our maximum 1.5, our minimum 0.3, our ratio 5. So these numbers are not even close. A brutal failure, but that's okay. That's what it's like working in AGI. Sometimes you just have to workshop things and get to a point where you're successful. So we're going to go back to render and see what went wrong. Okay. So we can see that when we translated these things up, it's really, really important to set your mounting height first, because when we translated these things up, it looks like the aiming points ended up as well. They moved along with them. So this is going to be an important lesson to teach us one more functionality in our step 5, which is adjusting to meet code, which is re-aim luminaires. So we're going to take each luminaire and we're just going to place it one more time right around where we had it, but this time they are aimed first before being moved. After being moved. And we're just going to re-aim everything. Click on it, it'll turn gray. It'll give you an option of where to re-aim it. And we're just going to one more time go ahead and press calculate. All right, we can notice our numbers are quite different now. We have at least 1 foot candle average, that's awesome. We have at least 1.1 foot candle minimum, we have that. Our ratio, however, is a little bit high. Now what that tells me is we either need our minimum to be higher. Since our minimum is 0.2, we could either bring that up or we could bring our maximum down. Now the easiest way to handle this, if I know that the ratio is off, I'll just try to lessen the intensity of the lights. So a good way to do that would be to aim them just a little bit farther away. So I'm going to go to re-aim, and I'm going to, on these ones, I think these would be the problem. I can look at the points and try to dissect it, but I'm just going to try to aim this guy. See this snap to? This is another issue that runs up. The snap to is forcing me to aim in the corner. I'm going to turn this off so that it doesn't, and I can aim it wherever I want. I'm going to do the same thing over here. Do the same thing with this one. All right, and we're going to press calculate one more time. And we're going to look, and we have at least 1 foot candle average, at least a minimum of 0.1, and our ratio is under 40. That means we have just met code. And that is how you lay out an emergency lighting space in AGI32. Awesome. Well, thank you, Tom. The only thing I would add to that is if we were not successful with that and we tried to keep re-aiming things and we just weren't able to get the illumination levels we needed, perhaps we would go in and add a couple of luminaires. You'd add one at a time, see, oh, would this work? And continue to move on. Anyway, we do have a bonus for you here. You can also size an inverter with AGI32. What's needed for that? Same basic elements, IES file. You need to know the heights of everything. And for this, it's probably a little bit more crucial to have a CAD file, especially if you're working in a larger space. The steps to this are pretty similar in the beginning. Only difference is that you are going to be using non-emergency fixtures, which you'll have to find the IES file for those. And you're just going to add up all the wattages of all the total fixtures that you've placed. And that's going to be about 80% of what we would recommend to you in terms of an inverter size, just to leave a little window for safety. After that, you're just going to go to isolite.com, find the spec sheet of the inverter you'd like, specify all the options you'd like, and then just send us an email at quotes@isolite.com. There will be a follow-up sales packet with a link to this video. All of our IES files and spec sheets are available on isolite.com. Well, I thank you guys so much for listening. I am Tom Deutsch again, and together with Evan Ackman, Greg Keel, and Matt Bird, we are here for you. Anything you need, feel free to reach out. My email is right there. Especially with anything AGI related, if you have any questions, why don't you go ahead and post them in the Q&A now. And if you think of anything else after this, send me an email.